exceptional stability, why it has exceptional properties unlike alkenes, though it is unsaturated. So, but today lecture, so I'm going to discuss about, so in the today lecture, I'm going to discuss about the preparation of benzene. Actually, the benzene is the compound hydrocarbon extracted or isolated from the coal tar. You know, the coal tar is the byproduct obtained from the crude petroleum oil while doing fractional distillation process. But the benzene also can be prepared or manufactured by the laboratory method also. We can get the benzene. So by the process called cyclic polymerization. So look at this equation. When 3 moles of ethyl molecules, when passing through the red hot iron tube at 873 Kelvin temperature, we can get the cyclic structure called benzene. The cyclic structure is obtained. So when ethyl molecules are interacting in the chamber, so the triple covalent bond is polarized. So then the positive charge attract the negative of the carbon. So negative charge attract the positive charge. Automatically, the molecules are interlinked to form the cyclic structure called benzene is obtained by this process. So benzene is obtained by the cyclic polymerization of ethyl molecule. Now, second preparation method, decarboxylation of aromatic compounds. Decarboxylation of aromatic aromatic salts, we say. So decarboxylation of aromatic acid salts. And one more, third method is said to be reduction of phenol by zinc dust. So how this process is done, let us discuss. So see this compound. So what is this? This is called sodium benzoate. This is aromatic acid salt, we say. So the salt of benzoic acid, sodium benzoate. This is sodium benzoate. This is the sodium is a benzoate. When treated with this sodium hydroxide plus calcium oxide, this is called a mixture of this calcium oxide and sodium hydroxide is said to be what we call means soda lime. So in the presence of soda lime, the sodium benzoate salt upon heating, so then we can get so benzene and sodium carbonate we get. So this process is said to be decarboxylation because this carbon dioxide will be eliminated or removed from this reaction. So in the presence of calcium oxide and sodium hydroxide upon heating, then we can get the benzene structure. So this is simply is decarboxylation reaction of the benzoic acid. We say the sodium salt of benzoic acid upon heating with soda lime, we can get the benzene. So here this reaction has one specific importance. So what is the importance means in case of the conversions, if you want to decrease the carbon atoms, here the number of carbon atoms are 6 plus 1 7, but after the reaction the number of carbon atoms decreases. So the 7 will become into 6. 1 carbon we can decrease by this process. Decarboxylation of sodium salt of benzoic acid is done in the presence of soda lime. Okay, another reaction is by reduction of phenol. So phenol, so on the benzene ring there is OH. OH group is present on the benzene ring. When the phenol is subjected to means heating in the presence of the zinc metal, so zinc metal if it is done, so the zinc will abstract this oxygen and forms into zinc oxide. So the hydrogen is attached to this carbon, then we can get so benzene structure we can get. So this is what we call the reduction by the zinc metal, we say, then we can get the benzene. So when phenol subjected to reduction process, we can get the benzene. So the benzene is obtained, the benzene molecule is obtained, benzene is obtained so by the zinc metal, means reduction of the phenol by the zinc metal here. Okay, so these are the laboratory methods used for the preparation of the benzene. One is from cyclic polymerization, other from decarboxylation of sodium salt or benzoic acid. Third one is reduction of phenol by using zinc dust that is. So the benzene can be prepared by this method. So what are the properties? What properties can benzene exhibit? So, since the benzene is aromatic hydrocarbon, hydrocarbon basically benzene is non-polar. Non-polar aromatic hydrocarbons are non-polar in nature, so they are colorless, liquids and solids, and also solids. So, like naphthalene is a solid and having that aroma. What is the aroma means? Giving pleasant smell, good smell, perfume. And so naphthalene balls, already you are familiar with the naphthalene balls used in the toilets, and preservation of cloths we use, and gives unique smell of the naphthalene, and these having that property of moth repellent property, we say moth repellent property, hence we use in that so preservation of cloths we use naphthalene balls. We can put 2-3 naphthalene balls in the cloths. So so if you put that naphthalene balls, then the moth cannot, or the insects do not attack the cloths because of this naphthalene. And very important property, aromatic. So these hydrocarbons, aromatic hydrocarbons are immiscible in the water. Immiscible, what is the meaning of immiscible? Means insoluble in the water, but readily miscible. They form the miscible solutions with the organic solvents, and if they burn, so aromatic hydrocarbons burn, so they produce sooty flame, means more carbon monoxide and carbon monoxide, they produce sooty flame. So means, and aromatic hydrocarbons produce pollutants while they burn, whereas alkanes will not produce this carbon monoxide and sooty flame, but aromatic hydrocarbons. So with this we can identify aromatic hydrocarbons based on this burning property, also with sooty flame. So, aromatic hydrocarbons dissolve in organic solvents. So not in that of water, we say, not in the water, in organic solvents. So like carbon tetrachloride, so it can dissolve. And now coming to this chemical properties, what chemical properties do the benzene exhibit, aromatic compounds exhibit? So arenes particularly undergo electrophilic substitution reactions, rather than addition reactions. Actually, the benzene should undergo addition reactions more than the electrophilic substitution reactions, like alkenes. But it was shown that benzene or arene compounds undergo electrophilic substitution reactions rather than the addition reactions more. So now the most important reactions, chemical properties of benzene or arene compounds shown by electrophilic substitution reactions are the common, unlike addition reactions, and undergo special conditions. They undergo oxidation reactions also. That means the fundamental characteristics or fundamental reactions shown by the arenes is that electrophilic substitution reactions. So what are these electrophilic substitution reactions? Let us discuss the electrophilic substitution reactions of the benzene. So some typical example means we'll discuss the electrophilic the common electrophilic substitution reactions of arenes is that number one is what we call this is nitration. Nitration is the common electrophilic substitution reaction. Second one is halogenation. halogenation and sulfonation, Friedel Crafts alkylation and acylation reactions of the electrophilic substitution reaction. Since the benzene has nucleophilic nucleophile property, it attracts the electrophile. Since it has the electron-rich system, benzene is electron-rich system having that nucleophile property. So definitely the benzene attract the electrophiles. That means benzene possesses the pi electron system and pi electrons are more, so then easily and it attract the electrophiles. So let us discuss electrophilic substitution reaction of nitration. So the first reaction is nitration. So in this electrophile, what is the electrophile in the nitration process? In the nitration, generally what happens when benzene, if you take the benzene, so in this nitration process, if you take arene compound example, I am taking one example is, so what is that? This is the benzene. So when benzene is treated with this concentrated sulfuric acid, H2SO4. So concentrated sulfuric acid and it is concentrated sulfuric acid H2SO4 and HNO3 when it is treated with concentrated nitric acid HNO3. So when benzene is the arene compound, so when this arene compound is treated with concentrated sulfuric acid and concentrated HNO3, so we get the compound is, so what is the compound we can get? The product is, so nitrobenzene, we can get the nitrobenzene compound. That means the benzene is converted into nitrobenzene when it is treated with this concentrated nitric acid and concentrated sulfuric acid mixture. So means the reaction of arene with the concentrated sulfuric acid and concentrated nitric acid, then we get the nitrobenzene is the, this reaction involves this electrophilic substitution method. And in this electrophilic substitution reaction, so what is the electrophile here? So how this nitrobenzene is prepared, so how the nitrobenzene is manufactured from this benzene when it is treated with this the concentrated sulfuric acid and concentrated nitric acid mixture. So if you want to understand this, so how this electrophilic substitution reaction goes in this, then what is the electrophile? If you want to know, then so we will discuss the mechanism of this nitration process. And in this nitration process, in the mechanism of this nitration process, the first step, so that is involved in this generation of electrophile. So what is electrophile in this reaction mixture? So what is the, when this sulfuric acid and HNO3 react together, then what is the electrophile? Which electrophile is generated? Let us look. In the mechanism, if you study the mechanism, there is first step is generation of electrophile. So electrophile is, so nitronium ion is generated. Nitronium ion, so you look at this structure, nitric acid structure. So when concentrated nitric acid is mixed with this concentrated sulfuric acid. So actually here very important thing is concentrated sulfuric acid, concentrated nitric acid, both are concentrated. So, and most means the reaction is exothermic. So, but how this reaction takes place when concentrated sulfuric acid react with the concentrated nitric acid, here one interesting thing will happen. Nitric acid behave like the base, whereas the sulfuric acid behave like the acid in relation to each other. So, and then, so here nitric acid behave like the base and sulfuric acid behave like the acid. Then here the protonation is protonation is done for the nitric acid. Protonation is done for the nitric acid. That means here the nitric acid. So nitric acid accept the proton from this sulfuric acid. Nitric acid accept the proton from the sulfuric acid. Then so the bond between nitrogen and oxygen will break. This bond is broken. NOH bond is broken due to the protonation. Oxygen get the positive charge here. So then, when the bond is broken here, then so nitronium ion is formed. Nitronium ion is formed, and H2O is formed here. Nitronium ion is the electrophile. This is the electrophile which attack the benzene ring. So this electrophile nitronium ion is produced from the nitric acid. Nitric acid when react with the sulfuric acid, then this electrophile attack the pi electron system of the benzene. Benzene has the pi electrons. The pi electron is donated to this nitronium ion. So and the nitronium ion making bond with the carbon. Then so carbon get the positive charge, benzene get the positive charge. Then these pi electrons will undergo resonance forms. Here I am not mentioning the resonance structures of this. This carbocation. I am not writing this. So benzene carbocation resonance structures. So and in order to compensate this positive charge, the hydrogen atom present on this carbon, the sigma bond will be converting into the pi bond. Then nitrobenzene is prepared. This proton is abstracted by either bisulfate ion or this water molecule, or take this proton and form into hydronium ion. This hydronium ion give the proton to this bisulfate and forms into sulfuric acid again. That means in this reaction, sulfuric acid acts like a catalyst, and the nitric acid react with this benzene. The role of the concentrated sulfuric acid behave like the catalyst, we say. So here in this nitration process, nitronium ion is the electrophile. That electrophile is added to this benzene, because benzene consisting of the electron rich or pi electrons. So those pi electrons given to this electrophile, and the reaction between this benzene and nitronium ion will form nitrobenzene is the compound. Nitrobenzene compound is formed. That means in this reaction, so generation of electrophile called nitronium ion between the two acids, when the two acids will interact. And step 2 is attack of this nitronium ion on the benzene ring. Step 3 is losing of this proton, liberation of this proton when the bisulfate ion attack this proton, then formation of concentrated sulfuric acid. So this is the mechanism that is associated with this electrophilic substitution reaction of the benzene, which is the main component of the arene, we say.